Hi, so for today we're going to talk about integrals of powers of trigonometric functions, more specifically the sine and cosine, the integrals of power of trigonometric functions for sine and cosine. So basically, this is a part of integral calculus, and how do we solve if we have a given integral like this, such that we have the integral of sine raised to m x cosine raised to n x dx, where m and n are actually powers, so greater than 1. Okay, so how do we solve the given integrals such as this? Now, in solving integrals such as this, we need to apply some certain identity, and that identity, specific identity, is actually from the Pythagorean identity of sine squared x plus, let's say, sine squared theta, or plus cosine squared theta is equals to 1. Okay, so the identity that we're going to use is this one. Take note that theta could also be y, could also be x, depending on the variable. And we have two conditions. Alright, if n is odd, which means it's an odd number, okay, this is odd, split off a factor of cosine of x, and then we're going to apply this identity. On the other hand, if we have an m that is odd number, this is sine raised to an odd number, split off a factor of sine x. And we're going to use the identity sine squared x is equals to 1 minus cosine squared x. Okay? So there is a case-to-case basis on how we are going to solve for this. Okay, so to apply, okay, we have to solve some problems. Again, the only way for you to be good at this is to solve as many problems as you can. So let's try for the first problem. How about we evaluate the integral of sine cube 2/3 x, okay, cosine raised to 4 of 2/3 x dx. Okay, so basically, we are going to label this is our m and this is our n. Okay? Basically, our m here is an odd. So we are going to split a factor of sine 2/3 x, okay? Okay, into our integral. So if we do that, we'll be having sine squared 2/3 x. We split off one sine, cosine raised to 4 of 2/3 x. And that is now multiplied with sine of 2/3 x. Here is the splitted factor of sine 2/3 of x. Because if you're going to rewrite this, this is also equal to sine 2/3 of x raised to cube, okay? And multiplied by cosine of 2/3 x, okay, raised to 4, okay? So that's basically how we are going to write them also. So this is basically equal to this. So we have split off the factor of sine squared, okay, 2/3 x, and we have sine 2/3 x here. Now, we can think of that if we split one factor of sine 2/3 x, this will be our du, because we are going to integrate this by simple u substitution. So if this is our du, okay, our u should be, okay, if this is our du, sine 2/3 x dx, that should be, we should have a u of cosine in terms of cosine. Agree or not? Yes, because the derivative of cosine is negative sine, of which we can have a correction factor of negative here, okay, in order for us to complete the u du substitution. Okay, so what will happen here next is that if this is our du, okay, if this is our du, we must make the necessary substitution of sine squared 2/3 x into cosine, because we want all of these remaining terms inside the integral to be cosine. Okay, so if I'm going to replace this, let's recall that we have an identity a while ago of sine squared x is equals to 1 minus cosine squared x. And in this case, our x is simply 2/3 x. Okay, this function inside the sine is not only x but 2/3 of x. So what is going to happen is that we have 1 minus cosine, okay, squared of 2/3 x, okay, multiplied by cosine raised to 4 2/3 of x, and then we have sine of 2/3 of x, then we have dx. And then Viola, we can perform u substitution by letting u as 2/3, letting u as the cosine of 2/3 x, okay? And then our du would be, of course, let's differentiate this. So the derivative of this is simply negative 2/3, okay, sine of 2/3 x dx, okay, of which sine 2/3 of x dx is already available here. It's already available here. So we need to have a connection factor of the reciprocal of this outside of the integral in order for us to simply substitute this. So what will happen is that we'll be having negative 3 halves, okay, outside of the integral. This is our correction factor because we don't have negative 2/3 again, okay, in our integrand, inside our integrand, okay. So we have negative 3 halves as a correction factor outside of the integral. So what will happen next is simply substitute. 1, this is our 1, minus, we let u as cosine 2/3 x. And this is raised to squared, so that must be u squared. Okay? Then, multiplied by u, this is our u, cosine 2/3 of x, it is raised to 4. And then, finally, we have the du. Okay? This would now be du because we already have a correction factor of negative 3 halves. Okay? Outside of the integral sign. So, it's actually okay to substitute this du in our integral. I hope you're getting what I'm trying to say. If you haven't viewed my videos all about basic integration, please watch it first before watching this. Okay, so what will happen here next is it's very easy. We know that negative 3 halves, we know that this would be distributive. Okay, we can distribute this such that it would become u raised to 4 minus u raised to 6. Exponents will add up, okay, if we multiply the two u's here. So we have negative 3 halves, integrate this, we have u raised to 5 over 5 minus u raised to 7 over 7, okay, plus c. This is by power rule. And if we are going now to distribute the negative 3 halves, we have negative 3 over 10, negative 3 over 10, u raised to 5, negative times the minus of here, this would become plus 3 over 14, okay, and u raised to 7 plus c. Of course, this is not our final answer. We should substitute back the original value of u into our final answer. So, take note that our u is equal to cosine 2/3 of x. So, we have negative 3 over 10 cosine 2/3 of x raised to 5 plus 3 over 14 cosine of 2/3 x raised to 7 plus c. And or in other words, we can rewrite it as negative 3 over 10 cosine of 5, or cosine raised to 5 of 2/3 x plus 3 over 14 cosine raised to 7 of 2/3 of x plus c. And this should be our final answer for this given problem of integral. A little recap of what we have done. Again, we split off one value of sine cube here because m is odd. So the thing is, if you are going to evaluate integrals with the powers involving sine and cosine, please find first which of the following two trigonometric function has an exponent that is an odd, and split that factor and then apply the identity, the necessary identity. So what we did is basically a basic example of the integrals of powers of trigonometric functions for sine and cosine. Alright, let's try another problem. So for this problem, evaluate the integral of sine raised to 8 3j dz. I'm sorry, this should have only one dz. So sine raised to 8 of 3j cosine multiplied by cosine raised to 5 of 3j dz. We know that this is our m, okay? and this is our n. And whichever is odd, okay, we split that off. So in this case, we have an odd exponent for cosine, so we're going to split one cosine. So we have integral of sine raised to 8, 3j, multiplied by cosine raised to 4, 3j, because I'm going to split one factor of cosine 3j in this. Okay? So this would be my splitted factor. And if I imagine that this would be my du, what must be my u? My u must be uh, in terms of sine. So this is in terms of sine, nothing to do with this one, but I'm going to transform this into sine by using again the identity, okay, that cosine squared x is equals to 1 minus sine squared x. Okay, in this case, I can what? Simply substitute this. So we have sine raised to 8 at 3j. Alright. So since this is actually raised to 4, so I have a cosine, I'm sorry, I have to have a 1 minus sine squared, okay, 3j. Now, this is cosine squared 3j, okay? But since it's raised to 4, okay, this should have a square. If you didn't get what I'm trying to say, is we split the two cosine here, okay? We split the two cosine here, the cosine for 3j, okay, into cosine squared 3j raised to 2. Okay? That's what we did. And we simply substitute the cosine squared 3j inside, which is 1 minus sine squared 3j. And since this is raised to 2 because of the exponent 4, now this is raised to 2. Okay? So we have cosine 3j. And we have already transformed all of the cosines here into sines, so that if we are going to perform the u substitution here, letting u as sine of 3j, okay, we get a derivative of u, which is 3 cosine 3j with respect to j. That's why we have dj. Notice that we don't have any 3 here, 3 cosine 3j, because we only have cosine 3j dj, which is this. So we are going to multiply a correction factor of 3, but outside of the integral sign, the reciprocal of that 3, which is 1/3. Okay? That's what we did a while ago also. So we have now 1/3. Okay? U substitution. So this would be u raised to 8. Okay? And that would be 1 minus u squared because of sine squared 3j. And then this is squared. Of course, multiplied by du. And we can now actually perform the integration by first expanding this 1 minus u squared. So this would be 1. This would be negative 2u squared plus u raised to 4. That's how we expand. Okay, first, we square the first term. The second term is found by multiplying all of them. 1 times negative u squared is negative u squared. Multiplied by 2, that is negative 2u squared. And the third term is found by simply squaring the last term together with the sign. So, negative u squared is squared. That's positive u raised to 4. So, we can now perform integration by actually distributing this u raised to 8 outside, okay, of the quantity. So, we have u raised to 8, okay, minus 2u raised to 10, okay, the exponents add up, plus u raised to 12 du. Of course, if we integrate this, this should be easy by power rule. This is u raised to 9 over 9 minus 2 raised to 2 over 11, u raised to 11 plus 1 over 13 u raised to 13 plus c. If I'm going to distribute the 1/3, so we have 1 over 27 u raised to 9 minus 2 over 33 u raised to 11 plus 1 over 13 times 3 is 39 u raised to 13 plus c. Don't forget to back substitute the original value of whatever the value of u is. The value of u is sine 3j. So we have 1 over 27, okay, sine raised to 9 of 3j Okay? Minus 2 over 33 sine raised to 11 of 3j plus 1 over 39 sine raised to 13 of 3j plus c. And let me just erase the parenthesis here. Okay? So, this should be our final answer for this problem number 2. Okay, let's try for the last problem for number 6. Let's try. How about we evaluate the integral of the cosine of cube of 1 half w sine raised to 5. We have 1 half w dw here. Okay? So, in this case, our m and n are both odd number. So in this case, we can either split a factor of cosine or either split a factor of sine. Now, whether you split a factor of cosine or a factor of sine, okay, it would be, again, an acceptable answer when you do the process of, correct process of integration at the end of the solution. That is actually, you will be only having an answer of it's either a sine or a cosine. That's the difference, but that is both an acceptable answer. So if I'm going to, let's say, to split off one factor of sine here, okay, such that I have cosine cube of 1 half wd. Okay? And split off one sine of factor, sine raised to 4, 1 half w. And then we have sine of 1 half w dw. Okay? I know that my answer would be actually in terms of cosine. Now, if you split a factor of cosine, and such that, for example, you split a factor of cosine here and this remain to be sine raised to 5, it's actually okay. You will be having cosine 1 half dw here. And your answer would be in terms of sine. Okay? And both of which are acceptable answers. Okay? So let me just try this one. Let's try to speak of one factor of sine. So our answer would be in terms of cosine. So we have split off one factor of sine. So this would be our du. So what do we want is that, so this should be, let's say we should be having cosine cube. So cosine cube of 1 half w. So we want this to be changed as cosine because we're going to use a u of cosine because we have an available derivative of cosine here, which is negative sign. We're going to compensate some factor. Okay, so we will be having, we should substitute sine raised to 4 1 half w by the identity we have again. We have sine squared x equals to 1 minus cosine squared x. So upon simplifying this, so we have 1 minus cosine squared. Of course, our angle here is 1 half w. Okay, this should be raised to 2 because this is again sine raised to 4. And what we have done on the inside, this is equal to sine squared x, but this is equal to sine raised to 4. So we have raised to 2 here. So that would be sine of 1 half w dw. And if you're going to choose u, let u as equal to cosine of 1 half w. The du, derivative of cosine of 1 half w is, of course, negative 1 half, okay, sine 1 half of w dw, of which sine 1 half dw is present. So we need to have a compensating factor of negative 1 half here. And we get the reciprocal of this and multiply outside of the integral as a correction factor. So the reciprocal of this is negative 2. Okay? So what will happen is we can now perform the u substitution. We have negative 2. The integral of u raised to 3. That is 1 minus u squared squared. And then we have du here. Okay? So what will happen? We have negative 2. Expand again. This So we have 1 minus 2u squared plus u raised to 4, and we have du. Again, distribute the u raised to 3. This is negative 2 integral. So distribute this. U raised to 3 minus 2u raised to 5 plus u raised to 7 and evaluated to du. Okay? So we have the negative 2. Of course, we have u raised to 4 over 4 minus 2 over 6 u raised to 6, okay, plus u raised to 8 over 8 plus c. As we can see here, this can be simplified. This would be 1/3, okay? And distributing the negative 2 on each term, we have negative 2 over 4. That would be negative u raised to 4 over 2, okay? Because negative 2 over 4 is negative 1/2. So we have a negative or positive, negative 2 times negative 1/3 of u raised to 6. That's positive 1/3 u raised to 6. Okay. I'm sorry, this should be 2/3 because we have negative 2 multiplied by negative 1/3. That's positive 2/3 u raised to 6. Then we have negative because of this multiplied into this positive u raised to 8 over 8. So negative 2 over 8 is negative 1 over 4. Okay, or 1/4 u raised to 8 plus c. And of course, don't forget to back substitute it. So we have negative 1/2. Our u is cosine, so we have cosine raised to 4 of 1/2 w plus 2/3 of cosine of raised to 6, I mean. So 2/3 cosine raised to 6 of 1/2 w minus 1/4 cosine raised to 8 of 1/2 w plus c. So as you can see, our answer is in terms of cosine. Cosine. So if we split a factor of cosine here, such that we have cosine 1/2 w here, our answer will be in terms of sine. And both of which are accepted answer. Okay? They are accepted answer. It depends on your u substitution. Okay? Because this has a two case of both of them are raised to an odd number, we can split off any. It's either cosine or sine. So, in this case, we split off sine so that we get an answer that is in terms of cosine. Okay? So if you want to test, if you have learned in this lesson, I have an example for you. I have an exercise for you. Can you, okay, evaluate the integral of this? Okay. So the answer is actually, I write also the answer. So 3/8 of t plus 1 over 8 sine of 40 plus 1 over 64 sine of 80 plus c. So again, thank you so much for listening. Don't forget to solve this. Try it on your own. You're going to use some trigonometric identity here in order for you to solve this, but the process is still the same. So if you don't have any suggestions, so thank you so much for your time in spending my watching my videos, and I hope you learn about this video, okay, about something about this video. So if you are new to my channel, please don't forget to subscribe to my channel. Thank you so much. Again, this is Engineer Abat, and God bless you.